In this video I'm going to demonstrate how we find the derivative of the natural log of x. But before we do that, there's a couple of little preliminaries we have to get under our belt. First is the definition of the number e. It's an irrational number, and one way to define e is as a limit as x approaches infinity of this expression, 1 plus 1 over x to the power of x. Now, a quick little demonstration here on the calculator I hope will help to convince you that this is true. So let's imagine we set x equal to 1, and then we evaluate this. 1 over 1 is 1, so 1 plus 1 is 2, to the power of 1 is 2. Not a very good value estimate for e, so the whole point about this is that x has to approach a very large number. So let's make it approach, say, 1,000. And when we have 1 plus 1 over 1,000 to the power of 1,000, we get 2.716. Now that's starting to look pretty close to e. E is 2.718. If I go just one more, let's go power of 1,000,000, then we get 2.71828. So we're agreeing all the way down to the 5th decimal point. So I hope that's enough to convince you that this definition of e is a valid definition. Certainly not a proof, but this is just preliminary. That's a reminder. Now, it's also handy to have an alternative version of this. The alternative is, it comes about if we make a substitution. Instead of 1 over x, what if we define that to be a variable v? Now, if we're going to change the variable in this, we're going to have to see what happens to v as x approaches infinity. So as x becomes very large, dividing by a very large number gives a very small result. As x approaches infinity, this new variable v would tend towards 0. So we can rewrite this definition, this limit, with v tending towards 0 instead of x tending towards infinity. 1 over x is replaced by v, that's exactly what we defined it as, and x, if we rearrange this, x would be the reciprocal of v. So this, similar but not quite the same limit, also would equal the same number e. With those couple of little preliminaries out of the way, we can get on to the main event. The main event is finding the derivative of ln x. So we go to our back to our definition of a derivative. The limit as h approaches 0, f of x plus h minus f of x over h. So this is first principles derivatives. And continuing here, what is our function with x plus h? It would be ln of x plus h. And what is our function evaluated to x? That's ln of x, still divided by h. So now we need to look at this numerator. Logarithms, when we subtract logarithms, it's the same as dividing their arguments. So we would have the limit, I've already written that, that should be the natural logarithm of x plus h over x. So that's the numerator. Now we still have divide by h. It's probably more convenient to multiply by 1 over h from here on in. So that's okay. And the limit as h approaches 0, I have 1 over h. And then the natural logarithm here, well, x divided by x is 1 plus h over x. Now at this point I'm going to make a substitution, a change of variable, a little bit like we did earlier. The thing that I want to change is this h over x. I'll define that as something new. So here I go. Let's just go up to the side here. let's define a new variable v, which equals h over x. Now, if we're going to define this new variable, we have to imagine what happens to v as h approaches 0. As h does approach 0, using this, we would see that, well, x is unaffected, only h is changing, and as h gets smaller and smaller, then if h became 0, 0 divided by a number would give v approaching 0. That's right. So back to our original work. We've now changed our variable to v, and we've just seen that v would approach 0. 1 over h. Let's imagine what 1 over h would be from here. We could have that v times x equals h by multiplying through the x. So 1 over h would be 1 over v times x. 1 over v, and I might split that as 1 over v times 1 over x as the replacement here. And I have natural logarithm 1 plus, now h over v, this was v. That's what we wanted. So x is no longer changing. X is only v changes in this limit. So 1 over x is a constant term. It can jump to the front of the limit. And I now have the limit as v approaches 0 of 1 over v times ln 1 plus v. Let's make sure you can still see that. So 1 over x is still here, and we have the limit as v approaches 0. Now, using our logarithm rule, when we have something multiplied by a logarithm, this is the same as if we have a power. Now that's starting to look a bit familiar. The limit of 1 plus v to the power 1 over v. That's what we had here. The limit of 1 plus v to the power 1 over v equaled the number e. So we can evaluate this now. 1 over x is still at the front. This is a natural log function, and all of this as v approached 0 turned out to equal e. Now, the natural log of e is 1. So the result is that the derivative of ln x is 1 over x.